Good day everyone, you're welcome to this YouTube channel. This is a continuation of sequence. This is sequence 2. In sequence 1 we discussed linear sequence, and in this sequence 2 it focuses on non-linear sequence. I want you to relax as we proceed. Non-linear sequence. So I want to start with examples of non-linear sequence. In linear sequence we have two types. We have arithmetic progression and geometric progression. When it has common difference, that is arithmetic progression, and when it has common ratio, that is geometric progression. Now indeed this is another type, and in this place this is an example. 5, 10, 17 and 28. You see that the difference between 5 and 10 is different from the difference between 10 and 17. Likewise 17 and 28. This is non-linear sequence. This is another one. -2, 3, 10 and 19. The difference between -2 and 3 is not exactly as the difference between 10 and 3 and 19 and 10. So this is another example of non-linear sequence. Likewise this one, difference between 4 and 10 is not the same thing between 10 and 18, likewise between 18 and 10. So all these, they are non-linear sequence. Now I want to talk about steps in non-linear sequence. This stage is very important and you need to take rapt attention. Now when you have a sequence like this is a non-linear sequence. Now we have step 1. If this step 1, the difference between 2 and 9 is equal to difference between 9 and 28, and between 28 and 29, 28 and 65, and between 65 and 120, it means it's linear sequence. But because this is not linear sequence, the difference between one term and the other will be different. Therefore, when we need to subtract these two, in this case we have 7, 19, 37 and 61. When you get to this level, when you look at it, this is still non-linear sequence. You see subtract again. Now in this step 2, if you want to get here is 2, 2, 2, let's see the difference between 7 and 19, 19 and 37. If the difference you have there is 2, 2, 2, it means at this level you will have time n square. N square is what you have at that level. But in this case, it's not linear as well. So we have this, which is not linear. But after this, we subtract it, we have 6, 6. So this is third step. At this second step, if what you have here is 2, 2, 2, it means n square. At this level, what you have here, like in this place is 6, 6. That one means is n raised to power 3. At step 2, it should be a multiple of 2. If it is 2, 2, 2, that is n square. If it is 4, that is 2n square. If it is 6, that is 3n square, and so on and so forth. Under step 3, it is 6. It should be at least 6. 6 means that it's 3n cube. If it is 12, that is 2n cube. If it is 18, that is 3n cube. If it is 24, that is 4n cube, and so on and so forth. Now I want to proceed to example so that you can understand better. Now this is an example. Find the end time of 5, 10, 17 and 28. This is not linear square as you can see. Now if you subtract this, we have 5, 7, 9. After this level, we have they are now equals. Now we have 2, 2. So this one means that we have n square here. Remember, if what you have here is 4, 4, 4 is 2 times 2. That is 2n square. If you have 6 here, I mean step 2, if you have 6 here, is 2 times 3. The least you should have at this second step is 2. So if you have 2 is n square. If you have 6, it is 3n square. If you have 8, is 4n square, and so on and so forth. Now let us proceed. Now I want to use this n square to make a term. 5 is the first, 10 is the second, 17 is the third, while 26 is the fourth. So we use it. So when n is equal to 1 for 5, we have 1 square, that is 1. When it is 2, we have 2 square, that is 4. When it is 3, we have 3 square, that is 9. When it is 4, we have 4 square, that is 16. So we have that thing. Then the original question given to you, 5, 10, 17, and 20, will come on top. Then you subtract. So when you subtract, we have 4, 6, 8, and 10. 4, 6, 8, and 10 is a linear sequence. So we can just use the formula for linear sequence to solve this one, where A is 4, common difference is 2, and N, so use that one. We'll continue here. So A is 4, D is 2, common difference is 2, then N. Then we have Tn is equal to N plus, Tn is equal to A plus N minus 1 bracket D. So A is 4, I just plug in. Then I open that bracket, 4 plus 2n minus 2, then that will give me 2 plus 2n as my answer. So whether you write 2 plus 2n as your final answer or 2n plus 2 is the same thing. So the final answer, remember that we got n squared before. So the final answer will be n squared plus 2n plus 2. I want to test this answer, whether our answer is correct. I will just use the first and the second one. So for this 5 is the first. So if I remove that n, I use 1 to substitute for n. I have 1 square plus 2 multiplied by 1 plus 2. So 1 square is 1. 2 multiplied by 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. So 5, that one is correct. I want to test for 10. 10 is 2 because that's the second term. So 2 raised to power 2 plus 2 multiplied by 2 plus 2. 2 raised to power 2 is 4. 2 multiplied by 2 is 4. 4 plus 4 is 8. 8 plus 2 is 10. So it shows that this answer is correct. Let's do another. This is a past paper. This is a question. Find the nth term of, we want to know for A, this sequence. So for this sequence, if you look at this sequence, 8, 15, 34, 71, and 132, this is a non-linear sequence. So just step 1, we have 7, 19, 32, 61. So we proceed. At this level, we have 12, 18, 20, 24. You know, this is the second step. So at this third step now, we have 6, 6. 6, 6 means that it is n cube. So this one is n cube. So I will use this n cube to form another square. You know, I have, when it is 1, I have 1 raised to power 3, that is 1. When it is 2, 2 raised to power 3 is 8. When it is 3, 3 raised to power 3 is 27, and so on and so forth. So I form this sequence. So I will put the original sequence on top, then I subtract. So I will have, here I have 7, 7, 7, 7. So my final answer here will be n raised to power 3 plus 7. This is the B part of the question. I want to find the nth term. If you look at this type of sequence, we have the numerator and have the denominator. If you look at the numerator, 2, 3, 4, 5. So it's like that one is plus 1, plus 1, plus 1. So that one is AP. Now, A is 2, D is 1, and N is n. So when I use that one to form, your Tn is equal to 2 plus n minus 1 bracket 1. And y is the common difference. Then the first term is 2. So I open that bracket. I have 2 plus n minus 1. So when I solve that one for that, I have 2 minus 1. That is 1, 2. We have 1 plus n or n plus 1. Now for the denominator, you know, if you look at that denominator is a GP. Tn is equal to AR raised to power n minus 1. So this one will give me 1 multiplied by 4 n minus 1. So that will give me 4 raised to power n minus 1. Now the answer, the nth term for this, I will put the answer for the numerator, which is 1 plus n, all over the answer for the denominator, which is 4 raised to power n minus 1. So that will be my final answer for that. So this is another past paper. This question says, find the next term and the nth term of this sequence. So if you look at the numerator is 3, 4, 5, 6, 7, no, the next will be 8. So the denominator, I can see that it is plus 2, plus 2, plus 2. So if I just add 2 to the last one, so the answer for that one will be 8 over 15. So we want to find the nth term now. To find the nth term, I will consider for the numerator, I will just the first one is a is equal to 3, the common difference is 1. Then put it inside the formula. If I open the bracket, I have 3 plus n minus 1, which will give me 2 plus n. For the denominator, a is equal to 5, d is equal to 2. Now, to do that one, use the because both the numerator and denominator a, both of them are AP. So put in the formula, I have 5 plus n minus 1 bracket, which will give me 5 plus 2n minus 2, which is equal to 3 plus 2n. Now, so the answer will be 2n all over 3 plus 2n. This is another past paper. In this past paper, find the nth term of each sequence. No, the Roman figure 1 now. If you look at this question, you can see that this is a linear sequence because if I subtract the second term, minus 3 minus 1, that will give minus 2. Minus 5 minus, that's minus 2. So here, common difference is minus 2. So a is minus, the first term is minus 1, common difference is minus 2. So when I solve this one using the formula for that, I will get minus 1 plus n minus 1 bracket minus 2. Remember that I said that especially when you have common difference as negative, it's better to put it in the front to avoid mistake. So you can better write like minus 1 plus minus 2 bracket n minus 1. So that will give us minus 1 plus minus 2n plus 2. So if you solve that one further, we get minus 1 plus 2 minus 2, which will give us 1 minus 2n. So the second one, 2, 9, 28, 65, and 20, we see that this one is not linear. So we first of all subtract that one, we get 7, 19, 37, 61. This one is not linear yet. I still subtract again. Then I get 12, 18, 34. You know, at this level is the third step. So the least I should have here, it should be 6. So, and if I subtract that one, I will get 60. So that one means n raised to power 3. So that n raised to power 3, I will use to form a new sequence. No, for the first one, it will be 1 raised to power 3. Second one will be 2 raised to power 3. The third one, 3 raised to power 3, 4 raised to power 3, and 5 raised to power 3. I will form the new sequence and place the question given to me. I will place it on top. So this is the sequence I just formed with n raised to power 3. When n is equal to 1, 1 raised to power 3 is 1, 2 raised to power 3 is 8, 3 raised to power 3 is 27, 4 raised to power 3 is 64, 5 raised to power 3 is 125. So I put the original equation on it. So when I put the original equation, I will subtract. So when I subtract, I get 1, 1, 1, 1. So this one means my final answer is n cubed plus 1. I want you to try as much as possible to lay your hand on as many questions as possible and possibly watch this video over and over again until you see that you have mastered everything very well. I'm sure that we get it. Bye for now.